Okay, so I am now recording it. So Sam, are you happy now? Okay, but yeah, you're right. I should have been recording it all along. Okay, so just a quick summary for the sake of those people who are watching the recording rather than being here live. We are currently working on problem number 23 from chapter number 5. And so what we've captured is the fact that we've got some bookcase that we're pushing across the floor. And uh, so then we're pushing a little bit harder than the friction force is capable of resisting. So the bookcase is accelerating. Oh, this is interesting. Okay, so we just had somebody type into the chat box. They actually prefer when it's not recording so they can ask embarrassing questions. You've got a good point. You've got a very good point. Oh, it's all right. Okay. All right. Well, tell you what. What I'll do is if you want to ask a question that you don't want recorded, then tell me in the chat box that that's what you want to do. And what I'll do is I'll pause the recording and then we can have our conversation without it being recorded. And then once it's done, then I'll start recording again. How's that sound? Okay. So we okay recording this right now? And then if you have a question, you can type your question into the chat box and that way nobody will know who asked the question. How about that? How's that for a good compromise? Okay, so let's get back to working on this. So I need somebody to suggest a way that we can solve this problem because I don't remember how to do this. So, I mean, it's been 40 years since I took physics. So I need you guys to help me out here. Yes. Okay, how are we gonna approach this, guys?
Aren't we going to use like one of the equations of motion?
Maybe. Okay, let me guide you with some questions here. Okay, let's start with the thing that we're looking for. So we are looking for, let me get a different color here. Okay, so we're looking for mu. So let's kind of work backwards here. Yeah, and torturing kids. Yes, I like that. Okay, so let's work backwards. What equations do we know that involve mu? Well, how about the force of friction equals mu times the normal force? Okay, that's an equation that involves mu, right? So what we do is we say to ourselves, if only I knew what the normal force was, and if only I knew what the force of friction was, then I could calculate what mu is, right? So that now we say, okay, what would I have to do in order to come up with a number for what the normal force is? What would I have to do in order to come up with a number for what the friction force is? So let's do this one at a time. So let me ask you guys, and if you want to answer in the chat box rather than saying it out loud, that's okay. So what would we have to do in order to come up with a number for what the normal force is? Is there anything over here in our free body diagram that might possibly allow us to come up with a number for the normal force?
Isn't it just the mass?
It's not going to be just the mass. Look at the free body diagram. On the free body diagram here, we've got this arrow going down and this and this arrow going up. One of those arrows is the normal forces, which is what we're looking for. So
Did you multiply gravity by mass?
yeah, mg is the answer. Because if we look at our free body diagram here, there's the normal force, which is what we want to come up with a number for. So we say, what is the normal force equal to? And then we say, oh, it looks like it's equal to mg, not just m, mg. Okay. All right, so the normal force is mg. And so we say to ourselves, okay, if that's mg, we know what m is because we know what planet we're on. Or, I'm sorry, we know what g is because we know what planet we're on. And we know what m is because m has been given to us. So good. So I'm thinking we're in good shape. We can figure out what the normal force is. But what about the friction force? How could we come up with a number for what the friction force is? Anybody got any suggestions?
The weird squiggly 3 looking thing, F equals MA. I forgot what it's called.
Okay. Okay, I like that. Okay, so let's use the weird squiggly 3 looking thing, which is this. Okay, which is the Greek letter sigma, and what it means is add them all up. Okay, so we're gonna do sigma F, which means we're gonna add up all the forces. Now the friction force, is that acting vertically or horizontally?
Horizontally.
So, horizontally. So usually we call that the X direction. Yeah. So we normally say this is the X direction. This here, whoops, keep doing that. This here is the Y direction. Okay. And so what we're going to do is we're saying, since the friction force is acting in the X direction, let's just focus on the X direction only. And now, so we've started writing Newton's second law. Let's finish writing it. What else goes into this equation according to Newton for his second law?
We need to determine what our positive and negative is.
Okay, that's a good idea. I like that. So which way would you like to be the positive direction?
Left.
Just because you like to be different?
Yes.
Okay. So you guys realize it doesn't matter. Okay, so now we know the block is moving to the right. So normal people would choose the plus direction being to the right. But Sam is not a normal person. And by the way, that's one of the things I like about you, Sam. Okay, so let's make the plus direction be the left. Okay, but let's finish Newton's second law. So.
And don't you multiply mass and acceleration?
Okay. All right. So Lily is suggesting that Newton's second law says that sigma F equals ma. Very good. And I'm going to put a subscript X by the A here, just to remind ourselves that we're only focused on the horizontal direction. That's one of the neat things about physics that's going to help you if you learn this, is if you defunkify your funky vectors, and then just what you can do is you can create all of the horizontal components completely separately from all of the vertical components. Okay, so we're just going to look in the horizontal direction only. Okay, so if we add up all the forces that are acting in the X direction, then that'll equal mass times what the acceleration is in the X direction. Okay, and now I put my little bracket right here. And the reason I do that is because I'm going to now take the forces. So I want to take all the forces that are acting in the X direction and I want to put them down here inside the bracket. Okay, so looking at my free body diagram, that tells me where I get the stuff that's going to go under that bracket there. Let me clean up my picture a little bit here so it doesn't look so confusing. Okay, so we've got two forces that are acting in the X direction. You guys tell me what they are.
The force of people pushing and then the force of friction.
Okay, good. All right, so let's do them one at a time. So the force of the people pushing. All right, so let's put that in here, the FP. Now, is that going to go in with a plus sign or a minus sign?
Minus.
Okay, because we decided we were going to be different, because we know we could. And so the people pushing, they're pushing in the minus direction. So it goes in with the minus sign. And what was the other force you told me to put in here?
The force of friction.
Force of friction. Okay. Oops, sorry, I shouldn't have erased that. Okay. And so the force of friction, now does that go in with a plus sign or a minus sign?
Plus.
Goes in with the plus sign. Now, normal people would do it the other way around, but we're not normal. Okay. All right. So now let's bring down everything over here. So that's equal to mass times acceleration in the X direction. All right. So let's see. Okay, so we know the force of the people pushing, right? So that is 65 newtons. And we know the acceleration. The acceleration, they told us that it was 0.12 and we wrote it down as a positive number. But then Sam said that she wanted to define the plus direction going to the left. And so the way that they've written the problem, the book is accelerating, or the bookcase is accelerating the right. So what does that mean about our acceleration? Is it going to be a positive or a negative 0.12?
Negative.
It's got to be a negative. Okay. All right. So let's see what we got here. So we know what the acceleration is. We know what the mass is. We know what the force of us pushing is. So if only we could figure out what the force of friction was, well, that's it right there. So I'm thinking if we use this equation right here, the only thing in this equation that we don't know is the force of friction, right? So using this equation down here, we can come up with a number for the force of friction. So we can put that in here. So that means we can come up with a number for that. So if we go back to the original thing, remember the original thing here is we're looking for mu. So we take this equation here. So I'm thinking we're good. We can figure out what Fn is, thanks because we know that's mg. We can figure out what the force of friction is because we know it's from down here. Once we do that, we can get mu. Bingo, I think we're in good shape here. Okay, so what I propose we do is I'm going to sit here quietly and I'm going to let you guys do the math. And I'll even pause the recording because there's no reason to record a long break where nothing's happening. Okay, I've just turned the recording back on again. So what I've seen in the chat box here is a whole lot of numbers that do not agree with each other. So I'm thinking we better do this together. So let's do it step by step. Let's start off with mg. Okay, so can you guys please type into the chat box what number are we going to get for mg? And while you're doing it, I'll do it too. And type it in privately in the chat box. And what did we say m was? Okay, all right, good. Looks like we're all in agreement what mg is. So 401.8.
And we're not supposed to round the sig figs till the very end, right?
That is correct. We do not want to round sig figs. Okay, let me just make my 0 look more like a 0. Okay, so we're all in agreement what mg is. Okay, so now let's see if we can figure out what the force of friction is. So we know m, we know a, and be careful about minus signs. Okay, this a is not a positive 0.12, it's a negative 0.12 because we were feeling in a mischievous mood a few minutes ago, and we decided to make our plus sign going to the left just to prove that we could, just to prove that it doesn't matter. Okay, and so our pushing force, make sure you put in with a minus sign. Okay, so everybody come up with a number for what the force of friction would have to be. And let's see if we all get the same number. Okay, I've got a number. I see two numbers in the chat box. One of them is, oh, now I'm seeing 3. Oh my goodness. When I see 3 numbers and all 3 of the numbers are different, that has me worried. Okay, well, let's do this together then. All right, let's just take MA. Let's figure out, let me, I've got my screen is so cluttered here. Let me try to unclutter my screen a bit. Okay, so let's just do MA by itself.
Did you want us to also add the force of the people pushing or just the force of friction by itself?
Well, I want to know what the force of friction is by itself. I'm looking for a number that the force of friction is equal to. Right?
Hey, Hendrix. I was just wondering because I redid my work, and part of the issue that I had when doing it was that I canceled the mass when dividing by mg. Can you not do that?
Why did you divide by mg?
Well, because you get negative f p plus mu mg equals ma. So then you add fp to both sides, and then you have mu mg equals ma plus fp, and then you divide by mg so that you can get just mu by itself.
All right, so you're just trying to find mu by itself. Okay, that would explain why we're getting different numbers because what I had asked to do, or what I was thinking anyway, was I wanted us to take this equation down here and come up with a number for FP and then put that number up here and then solve for mu up here. That's what I wanted to do. So your way sounds like it would work very well. I have no problem with that. But we've already started into this other way here. So let's finish it the way that I've got here. So what I want you guys to do is I want you to take this equation down on the bottom here. And we're gonna see if we can solve this and come up with a number for what the force of friction is, so we can then plug that up in here and then solve from mu. So right now, the question that I'm asking you to do is come up with a number for the force of friction. Right, so that could explain why we're getting different numbers. Okay, so let's actually, let's do the algebra before we stick in the numbers. That's the way I always ask you to do it. So let's be consistent here. Okay, so what we're going to have to do then is we're going to have to add an FP to each side. So then we're going to get that the force of friction is equal to MA plus FP. Okay, so let's take that and let's solve that for FF. Okay, so you guys do that. Come up with a number. Now, the number I want you to come up with is the number for the force of friction, not yet the number for mu. I mean, ultimately, that's what we want, but let's do it step by step here. Okay, so Sam is making fun of my F. All right, I don't want to be ridiculed by Sam here, so let me fix that. Are you happy now, Sam? Okay, you keep life interesting. Keep doing that, Sam. Anybody got a number yet for what the force of friction is? Okay, I am seeing one number. I need to see a few more numbers. So I want you to take MA plus FP, and remember the way we've defined our coordinates, A is going to be a negative number, not a positive number. But the FP is going to be a positive number. Okay. All right. I'm seeing the same number now. What I'm seeing is 60.18. Except for one of you set in negative 60.1.0. Oh, I'm sorry, that's 08. That's not a 18, that's an 08. Sorry. Okay. 60.08. Okay, now one of you put in a negative 60.08. And so that's yeah, that it's positive. Okay, all right. Okay, so we're all in agreement now that force of friction is 60.08. So now we can stick it into here. So I'm thinking at long last, we can finally solve for the thing that we really wanted. So mu then, let's divide both sides by Fn. So mu then is going to be force of friction, which is the number we just came up with, divided by mg, which is the number we came up with a few minutes ago. So let's divide that by 401.8. Okay, so I've got a number. Let's see what you guys come up with. Okay, I see one number there.
So for our sig figs, it would be 2 sig figs because of the numbers we started with, right?
Right, yeah, so this is our final answer. And so now we can and should round off for sig figs. You are correct. But let me tell you a hint for getting partial credit on a Hendricks test, something that might come in handy. What I suggest that you do, let me clear some space here first. I can't tell you how frustrated I am that my whiteboard space is so small. I'm used to having great big whiteboards, like multiple whiteboards. Okay, so well, let's see. Before I write the number down, I want to see what you guys came up with because I'm a little concerned. I'm seeing several numbers here. Okay, so one person is asking me, how did I get 60.08? Because they're getting a different number. Okay, so tell you what, let's do that. Let me clear off a little space here. Get rid of all this stuff up here. Okay. All right. So, so M we know is 41. A we know is negative 0.12. The force of our pushing here we know is negative 65. Okay. Oh, wait a minute. Oh, no. Okay, now this is the problem with erasing all my old stuff here. Now I'm getting confused with my negatives here. Okay, so if I've got sigma F equals MA, when I put in the force of us pushing, I put in the negative sign over here. So when I put in the number here, I must not put in another negative sign because I already put the negative sign in here. So we put negative FP plus FF equals MA. Okay. So we already put the negative sign in over here. So when we put the number in here, we need to put in a positive 65, not a negative 65. Okay, so hopefully that explains that. Okay, so now let's get back to the question at hand. So they want to know, how did I get 60.08? Okay, so M was 41. The acceleration was a negative 0.12. The force of us pushing was 65, and we already took care of the negative sign. Okay, so what do I get here? So I get 65 plus a negative 41 times 0.12.
Why is the acceleration negative?
Because we wanted to prove that it was possible to define the negative, the directions any way we wanted to. So if you look in the upper left here, this thing that I keep circling, let me erase it again. Okay, so right here, we defined it to be plus to the left, just to prove that we could. Okay, and so if we know that the block is accelerating to the right, and we defined positive as being the left, that is why the acceleration there has to be a negative number. So, you know, Sam, I'm thinking that maybe that wasn't a good idea to define the plus sign to the left, just because it confuses people, not because we can't, but just because it confuses people. Okay, so are we doing okay? Got to teach those kids a lesson, man. Yeah. Okay, so that is how I got 60.08 for my force of friction. Okay, so now if I know that mu is equal to the force of friction divided by the normal force, so the force of friction is 60.08, the normal force is 401.8. So when I divide it out, the number that I get is, and let me clear some space here. Okay, whoops. Okay, so what I started to say a minute ago, and I got interrupted there, was, okay, in order to get partial credit on a Hendricks test, what I recommend is that you should write down on the paper, and let me do it in a pen that's a little bit more visible there. Okay, I suggest that you write on your paper mu equals, and then write down the number with a couple extra sig figs. So 0.1495. Okay, we got a couple extra sig figs there. Now we know that's not our final answer, but write it down anyway, because I can't tell you how many times I see this happen where students, they get the right number in their calculator and then they round it off improperly, but they don't write down the calculator number, they write down the wrong number. So like, for instance, let's suppose that we make a mistake, and when we round this off, and we round it down rather than up. So then we write mu equals 0.14, which you know, hopefully know is the wrong answer, okay? But if that's all they write, then I don't know whether they did the physics wrong or whether they just rounded wrong. So if you write down the number that your calculator gives you, and then give me an arrow, and then give me your final answer, okay, then if you make a mistake, if you make a rounding error and say 0.14, I can see that you got the right number and you just rounded wrong. And so what I could do then is if this problem is worth 5 points, I could give you 4 out of 5 points because you did the physics right. You just made a silly little mistake at the end. Does that make sense? Okay, so I just got a private message from a student saying that the negative acceleration was the problem. Okay, and I don't blame you. It can be confusing. So, so I would recommend that we define our plus directions to be the direction that the object is moving. Now, I'm not subtly roasting you. I thought it was good that you chose the plus direction in a non-traditional way because you can do it. Okay, there is absolutely nothing wrong with choosing the plus direction being to the left, except that it does, I mean, it sometimes confuses people, but if you are really careful about your plus and minus direction, plus and minus signs, you can do it. In the end, you will get the right answer. But for those of you that don't like to be confused, which is most of you, yeah, from now on, let's define our plus direction to be the direction that we know the object is moving. That way we won't have to get confused by this. Yeah, I'm a little sad too, but hey, that's life. Okay, are we good on this? Okay, you got any other problems you want to do?
Yeah, could we go over the quiz last time, and specifically the first and third question?
Okay, you mean the quiz that you guys should be doing right now? Quiz 5B or quiz 5C?
5B.
5B, okay. Let me just open up my Canvas here so that I can go find it. Okay. Sorry, it's going to take me a second to get this. Okay, so let's go into here. One of the modules. Go down to 5B. Go to the preview. All right. The ambient sound of a mouse clicking, yes. Okay, so which problems did you want?
1 and 3.
1 and 3. Okay, so a wooden box sitting on a floor. We know the mass of the box. We want to know what is the minimum force needed to start it moving. Okay, so I think I've got enough room over here on the left side here to draw a free body diagram. Let's see if I can do that.
I think I
Okay.
already figured out my mistake.
Ah, okay. Do the rest of you want to see problem number 1? Okay, so do you still want to see problem number 1 or you want to skip it?
What is this for? What quiz?
This is quiz 5B, problem number 1. I can still do it if you want, but if you think you found your mistake, well, then let's move on to.
Can we do it?
Okay, let's do it. Okay, so here's the box sitting on the floor, and we want to know the minimum force needed to get it moving. All right, so let's do a free body diagram. So we've got mg going down, got the normal force going up. We've got the force that we are pushing with or pulling with, doesn't matter. And then we got friction, which is opposing us. All right. And so now let's go and let's pull out the equation for the force of friction. So the force of friction is, now this is the static case. So that means it's less than or equal to mu s times the normal force. Okay. All right. So now, do you understand why it's less than or equal to? Because this is a static case. And so with the static case, if I push on something with less force than I really need to start it moving, it's gonna push back with the same force that I'm pushing with. So if I push with 1 Newton, it's going to push back with 1 Newton. If I push with 2 Newtons, it's going to push back with 2 Newtons. Okay, so it's going to keep matching whatever I do. So I can't put an equal sign in here because it's going to automatically change itself to match whatever I do. So there's a whole range of numbers that it can be, but it can only do that up to the maximum. Once I reach the maximum, then it's going to break free, right? So what I can do is, if I am looking for the maximum, then I can change this and I can have it be an equal sign, but only then if I recognize that the force of friction is going to be the maximum possible. Okay. So if I define the force of friction to be the maximum possible that it can possibly push with, then I can take that less than or equal sign and I can change it to be an equal sign. All right, so we're looking for this number here. So we need numbers for the mu s and we need numbers for Fn. So how could we get a number for mu s? Well, if we read the problem, it says it's a wooden box on a wooden floor. So if only there was some table somewhere that told us coefficients of friction for wood on wood. Well, in the book, they give it to you, right? Yes, 0.5, very good. Okay, and remember it's mu s, not mu k. So mu s is 0.5. Okay, so 0.5, 0, so 2 sig figs. Okay, so now we know what mu s is. Now how about Fn? How could we come up with a number for what Fn is? Well, if we look at our free body diagram, here's Fn, and we look to see, is there an arrow that's equal to and opposite to it? Yep. And so it's mg. So do we know what m is? Yeah, we do. Do we know what g is? Well, the problem doesn't tell us, but we can assume that we're on the planet Earth. All right. So if the problem doesn't tell you otherwise, it's safe to assume you're on the planet Earth. All right. So that means that we know g. All right, so now all we have to do is take 0.5 times the mass, which was 86, times g, which is 9.8, and bingo, we get the answer. All right, so I'm seeing one answer in the chat box here. I need to see a few more answers here. Okay. The person who typed their answer into the chat box, who I'm not going to name because I don't want to embarrass anybody, your answer is different than the number I got. Now, it could be me that made the mistake. I mean, that's certainly possible. Now I'm seeing 2 people get the same answer that's different from me. Okay, now a 3rd person just got the same answer I got. Good. I was getting worried there for a minute. Okay. All right. So 0.5 times 86. So 0.5 times 86 times 9.8. Yeah, when I do that, I get 421.4.
I thought you were asking us to find F normal.
Okay. Sorry. Okay, that makes sense. Okay. All right. Okay, so the final answer then, is it 421.4, or is there one more thing we need to do?
Sig figs?
Sig figs. If you look at the instructions here, let me clear everything up here. In the instructions, I told you how many sig figs to use, because what I've seen is that there are still a few students who are still struggling with sig figs. So rather than making you figure out on your own how many sig figs, I told you here how many sig figs. Okay. So if the calculator says 421.4, and I specifically said, give me 2 sig figs. Okay. So the answer we write in here is 420. So if we write the real number, well, I shouldn't call it the real number because it's not real, because this number, 420, is a better number, because if our input numbers only have 2 sig figs on them, and we think that a 4 sig fig number is the real answer, we are fooling ourselves. Okay. 420 rounded off to 2 sig figs actually is a better answer than 421.4. Okay. The number of the weed, yes. Okay, that was unintentional on my part. Okay, now you said earlier you wanted to see number 3. Is that still the case? You still want to see number 3?
Could you just give us an example problem of one of like the more longer problems just to go through, and then we can like have like practice? And it's
Yeah.
like the 26 from the homework, where
26
you have
from
to
the
use
homework?
the
Okay.
motion equations and stuff.
Okay, well, 26 from the homework, I did that in class and I did record it. So rather than doing number 26, let me suggest we do a different one. If you want to see number 26 again, let me suggest you go back and watch the recording.
Oh, no, I meant like give us a similar problem so
Oh,
that we
like
can
it.
work
Okay,
through
all right,
it
good.
and then figure
Okay.
it out
Okay,
on
can
our
do.
own.
All right, how about if I remember that special extra credit problem that I gave you where driving on icy hills? How about if we do one of those together? And then maybe I would even allow you to submit it for extra credit, even though I really shouldn't, because if we do it together, then, hey. But this will be your reward for showing up here. Oh, and you know what I'll do is I'll not record it. Because if I post it on the recording, then the people who didn't show up for the class here, they would get the points, and that's not fair. So I'm gonna pause the recording here, and then we'll do the extra credit problem about driving on icy hills. Okay, so I've just restarted the recording. So those of you that were here in person, you now know how to do the extra credit problems. Now the numbers that we used just now were not the same numbers as the extra credit problems. So you can't just take the numbers that we used and submit those as your answer. But the process that we went through is the same process. So those of you that showed up in person, you have a reward. Those of you that didn't show up in person, hey, you missed out. That's what happens if you don't show up in person. Oh, by the way, those of you that didn't show up in person, you're probably wondering why I'm wearing the wig right now. Okay. And I'm sure you can guess. Somewhere along the way of what we just did, I made a silly algebra mistake. So I'm paying the price now for that. Okay, so it's 10:18. We got enough time to do one more problem. You guys want to do another problem? Potato mistakes. What is a potato mistake? I've never heard that before.
It's something my dad says because I like to say that I'm a stupid little potato, and it's just like mistakes like switching 1.6 to 1.5, and I
Yeah.
continue the math with that number even though it's the wrong number.
That's a good term, potato mistake. Yeah. That's the kind of stuff I do all the time. That's why I'm wearing the wig right now, is because I made a potato mistake. Okay, you guys, you want to see any other problems?
Could you just give us a complicated problem that we do on your own and then we check back and then go over it?
Okay, all right, I can do that. How about if I do one of the problems from the homework?
Ooh, yes.
All right, yeah, okay, good. Let's see. One of my favorite problems, the kind of problem that I might possibly put on our next test, wink, wink, nudge, nudge, would be if I've got a ramp, let's say it looks like this. And I've got a pulley up here on the end of the ramp. And I've got a mass right here hanging from a rope that goes around the pulley and comes back. And then there's another mass over here. Right, so let's call this guy M1. Let's call this guy M2. Now, the way that I've drawn it, M2 is a lot heavier, so it's not obvious what direction these things are going to move. If this angle theta here, if that is a really steep angle, and if M2 really is bigger than M1, then it's entirely possible that when we release it, M2 is going to slide down the hill and it's going to pull the mass up. Okay. But if this angle is a small angle, then it's going to work the other way around. M1 is going to go down that way and M2 is going to go up here. So this is definitely a difficult problem. And I don't want to overwhelm you with too much difficulty. So tell you what, I'm going to make it a little easier for you. I'm going to say that M1 here is bigger than M2. Okay, so we immediately know that when we let go of these babies, M1 is going to go down and M1 is going to go, or M2 is going to go up. So let's define those as being our plus directions. So the plus direction for M1 is down, the plus direction for M2 is up. Okay, now let's see if there is friction. Let's say there might possibly be friction. All right, so there's going to be a mu value here. So mu is going to equal some number. And that number might be 0. So if that number is 0, then that means there's no friction. But that number might not be 0. So let's carry it along just in case. Okay. All right. So I propose to you that if we were to come up with a number for M1 and a number for M2 and a number for theta and a number for mu, you should be able to tell me what is the acceleration of these blocks. This is a great problem. This is exactly the kind of problem that I love to put on tests. Wink, wink, nudge, nudge. Okay, so let's assume that M1, M2, theta, and mu are all numbers that I will give you, but I don't want to give them to you right now because what I want you to do is I want you to come up with an equation for A. And so what you're going to give me is you're going to give me A equals some equation, and it might be a pretty messy equation. And somewhere in that equation, there's going to be an M1, and somewhere there's going to be an M2, and somewhere there's going to be a theta, and somewhere there's going to be a mu. Okay. So I want you to tell me what is the equation that will give me A. That makes sense?
So that means that you're giving us the mass of
Yeah.
M1 and
Yeah.
M2?
Yeah, yeah. Let's assume that M1 and M2 are known numbers. I mean, if you want, okay, if it makes you feel better, let's go ahead and put in numbers right now. But when we come up with the equation, I don't want the numbers in there just yet. But if it makes you feel better, let's put in some numbers. I'm okay with that. Okay, so Lila, give me a number for M1.
14.
Okay, 14 kilograms. Give me a number for M2 that is smaller than 14.
6.
6. And I'm going to say 6.0 so that we have 2 sig figs. Okay, Sam, give me a number for theta. And make it be a relatively small number, a number like something less than 20.
Okay, how about we do oh gosh. Okay, how about we do 15?
16?
15.
15, okay. All right, and Sam, while you're at it, give me a number for mu. And remember, mu has to be a number less than 1. If you ever do the math and you come up with a number for mu that's greater than 1, you know you messed up. It's always less than 1. And in fact, let's keep it relatively low. Let's keep it down to like something less than 0.3.
Okay, well that's literally just 2 other options. Okay, let's do 0.2.
Well, you could do 0.27 or you could do 0.16.
Wow. Okay. Okay. Let's do 0.22.
Okay, 0.22. All right. So now we do have numbers for all the m's and for theta and for mu, but don't use those numbers just yet. When we come up with the equation, we want to come up with a generic equation that will work for any m and any theta and any mu. All right. So let's come up with a free body diagram. Right. So for this guy here, I like my forces to be a little fatter there. Okay. So we're going to have M1G going down. And we're going to have the tension going up T. So I think that's it. That's all we got. Okay. Now, while we're at it, let's do a free body diagram for the other guy. All right. So we're going to have M2G going down. I'm going to have the normal force going up. And if we know that M2 is sliding up the hill, it's being pulled up the hill, we know friction always opposes that motion. So that means the force of friction is going to be going down the hill. Friction always opposes motion. And then what is it that's pulling it up the hill? Well, we got the tension. Better not forget that. All right. So I'm thinking we've got all of our forces here. So let me clear a little space here. We're going to need a lot of room. Boy, we're definitely going to run out of room here. I'll write small. Okay, so
Are we
let's,
trying to find the acceleration of M1 or M2?
it's going to be the same because they're tied together by a string. And if that string doesn't stretch, then whatever is the acceleration for M1 will be the same for M2. Does that make sense? Now, the direction of the acceleration is going to be different. M1 is going to accelerate downwards, whereas M2 is going to go up the ramp. So the direction of the acceleration will be different, but the magnitude of the acceleration has to be the same because they're tied together by a string. And now, if they were tied together by a rubber band, okay, then that would be more complicated. But it's a non-stretchy string. Okay, so let's look at this one piece at a time. Let's define our system to be just M1. Let's ignore everything in the world except for M1. And so when we do our Newton's second law, we're going to get sigma F equals MA, but this is M1, so I'm going to put an M1 there. And so now we do our brackets here. And wait, let's see, why am I doing this? You guys should be doing this. But, well, okay, whoops. You know, this is the problem with the wig. Sometimes my pen gets stuck in my hair. Oh, well. Okay,
How
so
the rest of us feel.
what's that?
That's how the rest of us feel.
Yeah. Okay, all right, so I don't see any way other than for me to do this, especially since we're running low on time. So let me just do it. Although normally what I would prefer is have one of you guys come up the board and I hand you the pen and I have you do it, but that's just not very possible. Okay, so if we've decided that our plus direction is down, that means M1G goes in with the plus sign. And the tension then goes in with a minus sign. So that's equal to M1A. All right, you guys agree I didn't make any silly mistakes there? All right, so now we've got an equation here. Whoops, oh, I keep doing that. I keep forgetting I'm in erase mode. Okay, all right, so we now have an equation and we know what the M's are and we know what G is, but we don't know T and we don't know A. And so at this point, it's time to stroke our chin again. It's time to say, I got two unknowns and only one equation. If I got two unknowns, how many equations do I need? Somebody answer that.
Dose.
Two, okay. Where could I get another equation from? Any suggestions?
M2.
M2, very good. Okay, so.
Oh
we-
wait, the M's on the equation that we just did, would they not cancel out?
No, they won't,
Oh, okay.
because you see the T here. There's no M's in there. If this term here had an M in it, then you would be right. Then they would cancel out.
Oh, okay.
But it doesn't
If
have.
you cancel it, it'd be killing a kitten. You learn it in math.
Yeah, we don't want to kill kittens. That would be bad.
Kill kittens, kill all the kittens.
Yeah. Okay. So let's focus our attention over here now, and let's use that to come up with another equation. All right. So let me do this in a different color even. Okay. So I'm going to do sigma F equals MA, but this time M2 is the one that I'm looking at. Okay, and this is going to get a little messy. I'm going to need a little more room here. So let me rewrite these guys over here because I'm going to need a little more room. Okay. So I'm going to take my bracket here and make it be a big bracket because I have a feeling I'm going to need a lot of space.
We have to
Okay.
defuncify, don't we?
Yes, we're going to have to defuncify. Good, good, good. Okay. Which one are we going to defuncify?
M2.
MG.
M2G. Very good. Okay, so we're going to draw our components like that. And so this guy here is going to be M2G times the cosine of theta. This guy here is going to be M2G times the sine of theta. And so now we don't need M2G anymore because we've replaced him with his non-funky components. Okay, so now let's figure out, now we're going to we only want the forces that are going in the direction that's the direction of motion. So that means we're going to this guy and this guy and this guy. Those are the forces that we want. And remember that the plus direction is the direction that we know the box is going to move in, which is going to be up the hill. So that means that T is going to go in with a positive sign. Force of friction is going to go in with a minus sign. And M2G sine theta is going to go in with a minus sign. Okay, so that then has to equal M2 times A. All right. Now, force of friction. What's the defining equation for force of friction? Well, force of friction is mu times the normal force. Now, you might be tempted to say the normal force is mg. Do you guys understand now that because we're not on a flat surface, it's not mg anymore? Normal force now is mg cosine theta. All right, so that means that the friction force is mu times mg cos theta. All right, so that means our equation up here becomes T minus mu mg cosine theta minus m, and by the way, that's an M2. And I'm running out of space here, so I better pack these closer together. So minus M2G sine theta equals M2A. All right, so there we are. There's the one equation. There's the other equation. So from this point on, it's no longer a physics problem. Now it's just a math problem, and you're good at math, right? Now, I admit it's a messy math problem, but it is just a math problem.
So then do you just add the two mu m2g cosine theta and then the other one too, and then so you could just t and then you input it in the other problem?
Okay, if I understood what you just said, the answer is yes, but I'm not 100% sure that I totally followed everything. So let me phrase it slightly differently. What we want to do is we've got a system of two equations with two unknowns. So we know that there's two ways we could solve this. Actually, there's three ways. If you've taken my engineering class, there's three ways. So one way is substitution. The other way is elimination. The third way is if you've taken my engineering class or my electronics class, you know that there's a way called matrix math. And matrix math sounds scary. And so people are very frightened of it. They say, whoa, it's actually really, really cool. But I don't want to take the time to show you how it works. So let's stick with the way that your teacher showed you. Of the two methods that your math teacher told you, substitution, elimination, I propose that elimination is going to be a little bit easier. And so I suggest we use that method. But if you want to use the substitution method, you can. And if you know how to do matrices and you want to do the matrix method, that's good too. All right, okay, so the substitution method says that what we're going to do is we're going to take everything that's on the left side of this equation and everything that's on the left side of this equation, we're going to add them together. And then what we're going to do is we're going to write an equal sign. And then we're going to take everything that's on the right side of this equation and add it to everything that's on the right side of that equation. Can you see that when we do that, we got a negative t and a positive t. They're going to cancel each other out. That makes sense? So what we're going to be left with is we're left with m1g minus mu times m2g cosine theta minus m2g sine theta. Okay, so that's everything over on the left side. And now I'm running out of space here, so equals. And then what I'll do is I'll write a bunch of stuff down here, but all this stuff down here really goes on the right side here. I hope that I don't lose you there. Okay, so everything up above equals the stuff on the right, which is m1a plus m2a. Okay, so you guys follow me there? So all of this stuff here equals this stuff. So all we have to do now is solve for a. Now the a's are they're all over on the right side of our equation. So what would you recommend we do to solve for a?
Divide by M1 and M2.
Well, before we do that, we're going to have to factor. Yeah, we have to factor out the a first. So what we're going to do is we're going to replace this with a times m1 plus m2. Now we can divide. Okay, but we couldn't do that before. We had to factor out the a first. All right, so now we can divide. So let's do that. Okay, so I'm going to divide this by m1 plus m2, and I'm going to divide all of this by m1 plus m2. Okay, so if I take all of this and I divide it by m1 plus m2, that then equals a. Bingo, that's our answer. It was a lot of algebra and a bunch of trig thrown in, okay? But here we have, this is our answer. So notice everything on the left side of the equation is a number that we know. We know m1, we know g, we know mu, we know theta. So we can now come up with a number for a. So at this point, it's just plug and chug. We're out of time, so I'm not going to actually put in the numbers. But do you guys trust that, yeah, we've done the hard work. From this point on, is just put the numbers in the calculator and get the answer.
If we like got to this point, let's say, and then we made a stupid mistake plugging it in, how much partial credit would you get if you turned in your work?
If this was a test question worth 5 points and you got this far, and then from this point on you messed up, I would give you 4 out of 5 points. Because you earned it. I mean, you did the hard work and you did the work right. And so I would absolutely give you 4 out of 5 points if you messed up from this point on. Okay, so I hope that was helpful. And I tell you guys, I won't even wink, and I won't even go wink, wink, nudge, nudge. Let me just tell you flat out, I guarantee there will be a question on the test like this. Absolutely, positively guarantee it. So make sure you know how to do it. All right, so we're out of time. All I can say then is good luck with the homework. And those of you that attended live, you now know how to do that extra credit problem about driving a car on a slippery hill. So yeah, that's your reward for attending live. Those of you that didn't attend live, hey, that's what you missed out on. Okay, well, I'm going to end the meeting unless there's any objections.
I just have one question.
Okay,
Probably told this a zillion times, but is the test that we're doing going on this quarter's grade or next quarter's grade?
next quarter, because we're not going to take it until next quarter.
Okay.
What I'm going to do next week is, even though we're finished with chapter 5, I recognize that this is tricky material. And I recognize that it's not something that people get the first time around. You need to see it 2 or 3 times before you get it. So I have a special lab activity planned for next week. I'm going to have you guys do a physics lab at your home that is related to the stuff that we just went over. And I'm going to have you write up a lab report about it and everything. So it's going to take you a couple days to do that. So by the time we get around to actually taking the test, it will be next term. So then obviously it's going to have to go. Okay, so I'm going to end the class then. Goodbye, everybody.
Thank you.
My pleasure.
Thank you.
Hi, Hendrix. Thank you.
Bye.
See, bye.
Bye.
Actually, there's like one thing I need to ask before I go.
Okay, do you want me to turn off the recording? Here, I'll do that. Let me turn it
Yeah,
off.
sure.
Okay, I'll turn off the recording.